Hello people, I'm Bharat Acharya. Welcome to our new video. In today's video we're going to learn SFRs. SFR stands for Special Function Registers. So there are 21 SFRs in 8051. They are special function registers. The name itself gives you an idea. Now they are different from the general registers. You know there is R0 to R7, 8 registers in one bank. Like this there are 4 banks. So there are 32 general purpose registers. R0 to R7 4 times. They are also registers. They are used by the programmer just for storing ordinary values. Okay? That's your registers. They are the tools used for programming. So they are called general purpose. Other than that, there are 21 registers also available to the programmer, but they are not used for storing ordinary values. They have some special use. If you want me to give you the whole list, I can give you right now. A, B, PSW. A and B are used for storing values during a program. A is the accumulator, B is used for multiply, divide, PSW is the flag register, P0, P1, P2, P3 are the port latches, SP the stack pointer, DPH and DPL form DPTR the data pointer, TCON, TMOD are used for programming timers, TL0, TH0, TL1, TH1 are used to hold the count for timers, IE and IP are used for enabling interrupts and deciding their priorities, SCON is used to program the serial port, SBUF is used to hold data during serial communication, PCON is used to decide the power saving mode, whether idle mode or power down mode. That's it. Those are the 21 SFRs. But no, there's no point looking at their whole list. That's just news reading. You'll understand these SFRs as and when you learn the topics. I'm sure by now you know the use of A and B if you see in the architecture. You know PSW, I've got a whole video on it. You know stack pointer, which we saw in the previous video, that is the structure of internal RAM. DPTR is data pointer, that again was covered in the architecture. So you know these registers, and P0, P1, P2, P3 are the port latches. They are used to hold value on the ports. The remaining SFRs you learn as you learn the topics. When you learn timers, you learn 6 SFRs. In serial port, you learn 2. In interrupts, you learn 2. And in power saving, you learn 1. So that's how you learn all the 21. But anyway, my point over here is there are 21 SFRs. They are available to the programmer. Programmer means you. Okay? Now, some of them have very interesting names. So there is an SFR called TCON, stands for timer control. There is something called PCON, stands for power control. There is something called SCON, stands for serial control, and so on. Now, since these registers are available to the programmer, you, that is the programmer, you will use them in some or the other instruction. That's the meaning of saying that they are available to the programmer. So when you write move A, TCON, your intention is to take the value of TCON into A register. Just you want to know what you have given, what is there in TCON. You want to read the register. Similarly, move A, PCON. Similarly, move A, SCON. Like this, since there are 21 SFRs, there will be numerous instructions like this. Every register causes a different opcode. When opcodes are formed, you know what is an opcode, the binary code of this instruction. There will be an opcode for move A, TCON. There will be an opcode for move A, PCON. An opcode for move A, SCON. That means there will be 21 opcodes. Because there are 21 SFRs. 21 opcodes for what? For move. 21 opcodes for add. 21 opcodes for subtract. Like this, you will run out of opcodes. There aren't so many opcodes that you keep giving 21 opcodes to every instruction. Are you understanding what I'm saying? There are 21 SFRs, but as you use registers, they also increase the number of opcodes. So somebody came up with this brilliant idea. See how intelligent people are. We are studying this. Imagine the IQ level of people who come up with this. What a groundbreaking idea, out of the box. Let's allot SFRs addresses. Do not confuse. I just said let's allot SFRs addresses. SFRs are not memory. SFRs are registers. Till now you thought memory have addresses, which is correct. Memory locations have addresses. SFRs are independent registers present inside the architecture. But to reduce the number of opcodes consumed, every SFR is allotted an address. So let's say TCON has an address 90. I'm just giving random numbers, okay? TCON has an address 87. SCON has an address 85, etc. So this instruction becomes move A, 90, move A, 87, move A, 85. Now there is an opcode only for move A. A number is never a part of an opcode. A number is written as an operand. So this is the opcode, this is the operand, this is the opcode, this is the operand, which means all your 21 SFRs can be used by using only one opcode. The opcode is for move A, the operand, the SFR is given as an address, which means as an operand. So everybody who learns 8051 knows that SFRs are given addresses because it's written in every textbook. Very few students really understand why they are given addresses. They are given addresses to reduce the number of opcodes. Are you clear? Now, another point. When you give SFRs an address, that address cannot be just any address. It should not clash with other memories, because otherwise to solve one problem, you are creating another problem. Look here. These are all memories of 8051. That's internal ROM, external RAM and internal RAM. Now, ROMs use 16-bit address. External RAM uses 16-bit address. Internal RAM uses 8-bit address. So, SFRs are allotted 8-bit addresses, because if you allot them 16-bit address, you will have to manage the clash with all these memories, so that would be too much of a problem. So SFRs are allotted 8-bit address, so the only clash you have to avoid is the clash with internal RAM. Now internal RAM uses 8-bit address, but very strangely it has addresses only from 00 to 7F. An 8-bit number can actually have a range from 00 to FF. Do you understand this? 00 to FF are 256 numbers. Internal RAM, strangely, is of only 128 bytes, consuming addresses 00 to 7F, which means there is a whole lot of addresses 80 to FF which are totally free. They are unused addresses. They are not used by any memory at all. All memories of 8051 are there on the board. The ROMs use 16-bit address. The external RAM uses 16-bit address. Internal RAM uses 8-bit address. Nobody uses addresses 80 to FF. What do you think? It's a coincidence? You think they just realized this, they saw all the memories and realized, oh my god, there is a set of addresses free? No. This is all a part of the plan. This is how 8051 is designed. It's a masterpiece of a chip. The way it has been created, there's so much intelligence gone inside. Internal RAM, they purposely kept it of size 128 bytes. I'm sure you all would be, the moment you heard this number for the first time, this is our 5th video or 6th video of 8051. The very first introduction I had said 8051 has 128 bytes internal RAM. When you hear this number for the very first time, it causes an itch in your minds, in your body somewhere. It can't be. 128 is such a stupid number to use. If they could have just kept it as 256 bytes purposely. They also had the temptation to keep a 256 byte, but no, they had control. They kept the one internal RAM of size 128 bytes so that you have a whole range from 80 to FF, which are completely unused addresses and can be allotted to the SFRs so that they do not increase the number of opcodes. So here, there are two things that you understood. First, SFRs are allotted addresses. Second, they are allotted addresses which don't clash with anybody. So SFRs are allotted addresses from the range 80 to FF. Did you understand this? Do not misunderstand. Students come up with their own concept of this. Oh, that means the internal RAM is 128 bytes, the first 256 bytes, the first 128 are visible to us, the next 128 are not visible. Usme say out of that some location the SFRs. No, I never said. SFRs are not any physical continuation of internal RAM. This is internal RAM, these are SFRs scattered all over the chip. They are just allotted addresses so that they don't create opcodes. When you write an address, it becomes an operand. It becomes separate from the opcode. So it does not increase the number of opcodes used. So you can access all your 21 SFRs without adding 21 opcodes for every instruction. Tell me, did you understand this? Now there is something more to understand, okay? There is something more, even more interesting. Look here. So port 0 is also an SFR. Its address is 80. Okay, we're almost done with this small thing. Port 0's address is 80. So when you write move, I hope you can see this. Move A, P0. This is assembly language. When you write it, it is written like this. When the assembler converts this into machine language, there will be an opcode for move A. There is no opcode for move A, P0, because then there would be an opcode for move A, P1, P2, P3, like this. There will be 21 opcodes. This is the whole reason why SFRs are allotted addresses. So for move A, assembler will substitute its opcode. For port 0, assembler will substitute 80 as the address. Please tell me, did you understand this much? So port 0's address is 80. Now, again, if you've seen the second video of 8051, I have given you a detailed description of all the pins. In that you will know, port 0 has 8 pins like every other port. All pins are bit addressable, which means you can access every line of port 0 individually without affecting the other line. Okay, it's a very useful feature. Now, so if you want to make this bit 1, you write an instruction like set B. Clear will make it 0, set B will make it 1. Set B P0.0 will make this bit 1. Similarly, if you want to make this bit 1, you write set B P0.1. If you want to make this last bit 1, you write set B P0.7. So what did you understand? What's the problem? Come on, there is a problem over here. Come on. If you understood whatever I've been talking, you should realize again, there is one perennial problem all over 8051. What? Opcodes. Look at this instruction. This is assembly language. When you convert this into machine language, the assembler will substitute an opcode. Will there be an opcode for set B P0.0? Nah, there can't be, because then there will be an opcode for set B P0.1. There will be another opcode for set B P0.2. Like this, there will be how many opcodes? 8. No, not 8. 32, because there are 4 such ports, and each port has 8 lines, and all 8 lines of all ports are bit addressable. That means there are 32 lines. So there will be 32 opcodes for set B, 32 opcodes for clear, 32 opcodes for complement. Can't be. There are not so many opcodes that you want distributing 32 opcodes for every instruction. So what does this mean? You want this bit addressable feature. You want to access these bits individually, but you don't want to create a separate opcode for each one of them. So what do? The same trick. Even these bits are allotted addresses. Listen, okay? It's a little delicate. These bits are also allotted addresses. Okay? What addresses are these? These are not byte addresses. These are bit addresses. Okay? They are allotted bit addresses. Now, you know, in the internal RAM, I hope you've seen the video before this, the structure of internal RAM. There is there are register banks. There is general purpose area, there is a bit addressable area which has bits which can be accessed individually. There are 128 bits having addresses 00 to 7F. 00 to 7F. Again, notice something very strange. So strange, but so wonderful. The bit addressable area has 128 bits, not 256 bits. Since it has 128 bits, the bit addresses used are again only from 00 to 7F, again giving you 80 to FF free as bit addresses. Internal RAM uses addresses 00 to 7F, giving you 80 to FF free as byte addresses. So 80 to FF are free as byte addresses also, 80 to FF are free as bit addresses also. SFRs are allotted byte addresses, and their bits are allotted bit addresses. So port 0 has a byte address 80, and port 0's bits have bit addresses 80 to 87. So what does that mean? If I do a byte operation like a move or an add or a subtract, etc., a byte operation at 80, it will affect the whole port 0. But if I do a bit operation like set B P0.0, that will also happen at 80. But since it is a bit operation, it will affect only P0.0. Please tell me, did you understand this? When I write move A, P0, assembler substitutes 80 for port 0. When I write set B P0.0, assembler again substitutes 80. But there is a difference between this 80 and this 80. This 80 means the whole port 0. This 80 means bit location port 0.0. How do we know which 80 we are talking about? The instruction clearly indicates this is a byte operation, this is a bit operation. That's it. That's what I wanted you to know about SFRs. In detail, you'll be learning the SFRs in the respective topics. So, what did I make you understand so far? There are 21 SFRs. SFRs are available to the programmer. As you use them, you'll be writing them in instructions. When you write them in instructions, they create opcodes. Because for every, as the register changes, the opcode changes. You cannot afford 21 opcodes. So, you write the name of the SFR for the sake of convenience. The assembler will substitute an address for every SFR. So every SFR is allotted an address. The addresses should not clash with any memory. Internal RAM is of size 128 bytes, so it uses addresses only up to 7F. 802FF are freely allotted to the SFRs. Similarly, in the internal RAM, there is a bit addressable area which uses bit addresses again only from 00 to 7F. So even in terms of bit addresses, 802FF are free and they are allotted to the bits of all the SFRs. That's it. That's what I wanted you to know. So this is the introduction, the idea of SFRs that I wanted you to have. You'll be seeing most of these SFRs like TCON, TMOD, SCON, IE, IP, PCON, PSW already have seen. The others you'll be seeing as we do the respective topics. Okay, see ya.